494L talks about laser beams and what they'll be doing as they go through the spaceship. So this is a Thomas wave theory, Thomas Young's double slit experiment, micro.magnet.fsu.edu/primer/java/interference/double slit/sunlight. No, and that's it. Sorry. I got my notes kind of getting squished in there. So it's molecular expressions, sunlight or laser beam. Goes at the top, down arrows. And it shows the single screen slit, the two slits, and it shows the diffraction of the coherent spherical wavefront. That's how the laser beam will diffract through those slits. Then it shows extra slits and how it diffracts even more. So it's reflected light, quote, Fourier transform projecting onto the plane orthogonal to K at each point K. Lines of waves point in step BAB. And lines of wave out of step. It's got JT plus K. So that's remember the transverse currents? We had that small transverse current perpendicular to the wave vector. There's the symbols for it. And you can see the same symbols on that line there, that trajectory there. Okay, so line of waves out of step. Again, you're going to have to look at this diagram on Alien Space Science News Photos.wordpress.com in order to get a really good look at it. I'm just doing the videos so that it can let you know what's the research I'm doing on it. So quote, it's a detector screen. So quote from Wiki, Thomas Young's extended wave theory of light to a large class of optical phenomena, especially to the double refraction property of ice and spar or calcite crystals. Let's go back up to this little diagram here we missed. It says detector screen, line of waves point and step shows dark fringe, BAB, bright fringe, BAB. So there's a dark fringe, bright fringe, and an interference fringe. It says component to light, which is your laser beam, retaining larger longitudinal component polarization light equals reflected light. Polarization by reflection. Light travels equal distance to point A. Light travels to a greater distance to point B. The wave from closed slit arrives earlier at B. So points A and B. There we go. There's points A and B showing where the light travels to A and how it travels to B. Okay?